Today, I'd like to speak about an advanced control strategy, which is going to be combined feed forward as well as feedback control. Now, by definition, we're going to find that it's a hybrid strategy where the feed forward part actually anticipates any disturbances and applies corrective action before they affect the process, whereas the feedback part is going to continuously measure the actual output and correct any remaining error that we are going to encounter. Together, they're going to give us faster disturbance rejection, greater stability, and higher accuracy than any other method that's going to get used on its own. On the screen in front of you, I show you a basic boiler. This boiler is going to have cold water coming in on the left-hand side, and we've got hot water going out on the top right-hand side. Now, in this particular instance, what I'm going to use is steam to heat up the boiler, the water going through the boiler, so that if the water is too cold, we can add more steam, and if the water is too hot, we can take the steam away. Now, the basic process would possibly be done as follows. We need to go and measure the outlet temperature. So we'll go and put in a temperature transmitter. And I'm just going to do this in blue. There's going to be a temperature transmitter, and that temperature transmitter would need to go to a temperature indicator and controller, and that would have a set point which the operators could go and adjust, and that would theoretically have to go to my steam valve to go and control the valve. Now I'm going to take that line away because that would be the basis of the feedback loop. But often we're going to find that we'll have a cascade loop that gets put in at the same time. So with a cascade loop, we possibly need to have a flow transmitter, and that flow transmitter would send its signal to a flow indicator and controller, and that would become the secondary part of my cascade loop. Now, for all intents and purposes, we would then take the signal from the temperature controller output and send that as the set point of the flow controller, and that's going to make the feedback part of this loop. I'm just going to take that line away because I'd like to go and add to it. Now imagine the feed forward part of this loop. Feed forward is where we're going to pick up a disturbance before the process is affected, and hopefully we can take the correct action from that. Now we could either have a change in the flow that was going to come in, or a change in the temperature, and that would be information that we can go and collect, and that would possibly form part of my feed forward controller. And the feed forward controller would make use of a model, and it's that signal that would have to get sent to the flow indicator and controller so that we can go and control the amount of steam. Now what we want to do is we want to combine the two controls together. So what I will do in my model that I set up, I will put in a summation device, and now what we will find is that the signal that comes from the temperature indicator and controller, the output from the temperature indicator and controller, will be summed together with the output that comes from my feed forward controller. And that combined output of the two is then going to be sent as the set point of the flow indicator and controller, and that's going to give us combined feed forward as well as feedback. So just to put this into perspective, that is going to form part of my feed forward loop, and this is going to form part of the feedback loop. We now end up getting the best of both worlds, and that will in many cases give us greater stability out in the field. Now what I'm going to do is I'm going to bring up a simulator, the simulator that I always use, and we will go and show you how all of this is going to fit together quite nicely. You will actually see the flow controller, which will work on the steam, and you will see the temperature controller, and you're going to see the combined effort of the feed forward and the feedback. The controller has already been set up just to operate with a combined signal that is going to be added together, and this will give us the control that we can go and achieve. Now that temperature controller is going to have its own PID settings, and the flow controller is going to have its own PID settings. And you might want to go back to the video that I have done on cascade control just to see the benefits there. Now let's take that control on the right hand side and run the process. And if you can imagine that the controller is in manual, if I was to take the output and open up the valve, which means that I'm going to give more steam to the process, you will see that the temperature of the process is going to go up. And if I was to go and close that valve, you are going to see that there will be less steam, and therefore the temperature of the process is going to go down. So that's how the process is going to be affected from a temperature point of view, and that is going to form part of my feedback loop. There's also going to be the feed forward part of the loop. I want you to look at that gray pen where I'm drawing the line right now, and imagine that is the load that is going into my boiler. Now, if I was to decrease the load, in other words, if I was to put less water into that process, then what you are going to find is that with less water and the same amount of heat, we are going to have the temperature that will go up. And just the opposite, if I was to put more liquid into the boiler, then there's more liquid for the same amount of heat, which means that the temperature is actually going to drop down. So that will be the part that I will use to describe the feed forward part of my process. Now, to get back to the fuel controller, I can go and put that controller into automatic. And that just means that the steam flow is going to have a set point. I can take the set point up, and that will give me more steam, and as you can see, the temperature is going to rise, and I can take that set point down and the temperature is going to drop. So purely a normal feedback loop that we can go and encounter. Then I want to try and put all of this together. So let's go and put the temperature controller into automatic and feed forward control, and let's just go make sure that the other controller is still going to be in a cascade mode, have everything up and running, and that should now allow us to do the final simulation. The operators would go and change the set point of the temperature, and as you can see, if they take that set point up, the feedback part of the controller kicks in. It's going to control the amount of steam addition that is required, and very soon the boiler is going to get to the set point that it needs to be at. If I was to take that set point down, you can see just the opposite happens. Less steam, temperature drops down, and very quickly we are going to get to the set point. So the feedback part of the loop works exceptionally well. Let's go and try the feed forward part. Remember that load that I have, I'm going to increase the load, and that means that we are going to have actually less heat for the additional amount of liquid that comes in. And as you can see, I've done nothing, and the controller has automatically gone and compensated for that by giving us more steam to heat the process up. Let's go and take the load down, put less liquid in, so theoretically the temperature is going to go up. The controller catches that by means of the feed forward control and takes us back to where we need to go and be. And that is it in a nutshell. We have a good example of combined feed forward and feed back control.